Moving on with solving radical equations. Again, by radical, it means that square root, okay? In order to solve the radical equations, we have to get the radical by itself first. Okay, so I have the radical here. How can I get that by itself? Subtract 9 over. Okay, do it. Subtract 9. So we have the square root of n equals 17 minus 9 is 8. Okay. Now we have to get rid of that radical. How do we get rid of the radical, do you think? What's the opposite of a square root? Start you with this. How did we solve equations like this? How did we get the n by itself when it looked like that? We took the square root, right? So we'd get n equals that positive negative 4. So how do we get rid of a square root? Put it to the second power. Yep. So we're going to square both sides. What you do to one side, you have to do to the other. So on the left, what's going to happen is the square and the square root cancel just like they did over here. And we're left with n. And then on the other side, 8 to the second power is 64. Done. Okay. So the biggest thing is make sure you get the radical by itself first. Okay. Look at number 3. What's the first thing that we want to do?
Subtract 5.
Yep, we want to get the radical by itself, so subtract 5 on both sides. Okay. Radicals by itself. Now how do we get rid of the radical? Square both sides. So what's left on the left? R over 7 equals 36. Okay, is R completely by itself yet? No. What's the last thing we need to do to get R by itself? Multiply by 7. Yep. So we get R equals let's look at number 5. First thing we need to do. Yep, because we want to get this all by itself. So add 2. So the square root of negative 6 minus 7x equals 6. What do we want to do next? Yep, square both sides. What is left on the left side after you square it? Just that inside part, right? So the inside part is left. Now it's your normal two-step equation that we have to solve. So what's first? Add 6. So we have negative 7x equals 42. Last step. Divide by negative 7. X equals negative 6. Yep. Good. All right. I want to talk about number 6 because it's a little bit different. We want to get the radical by itself. What was the first step that you did? Okay, I knew some of us would say that, and that's good that you did. Okay, but what's the relationship between the 8 and the radical right now? It's multiplying, so what's the opposite of multiply? Yep, we have to divide by 8 on both sides. So we get the square root of x plus 9 equals 4. Okay. Next step would be to square both sides. So we have x plus 9 equals 16. Last step, subtract 9, so you get x equals 7. So be careful if you have it look like this. If it's multiplying to the radical, you got to divide to get rid of it. we're going to problems that have multiple radicals. Instead of just one that we have to focus on, it has two. Thoughts on how to solve this one? Why can we square right away? Right, can we really do anything else? No, both radicals are by themselves, and to get rid of both of those, we could square both sides. So let's square both sides. So we're left with 2k minus 4 equals k. What's my next step? Subtract 2k. So we have negative 4 equals negative k. Can be tricky. Is k by itself yet? No. What's the last step? Yep, divide by a negative 1, so we get k equals 4. Yep. Good. First step. Some of you are already doing it. What are you doing? Square both sides. Yep. So we get b equals 15 minus 2b. Next. Yep. (3b) equals 15. And then divide by 3. So you get b equals 5. What's different about number 13? Has one radical. What's on the other side? It's a variable, okay? Is the radical by itself? Right now. Yes, so how can I get rid of the radical? Yep, I can square right away on both sides. So I have 6 minus b equals, what's on the other side? B to the second power, yep. Okay. What now? What'd you say? Okay, add b. But can I add b squared and b together?
No.
Okay, so what's on that other side? We have b squared plus b. Now what? Subtract 6. So we have b squared plus b minus 6. What's it equal to? 0. Okay. Thoughts? You could. So that's what? What method is that called? That's completing the square. We could do that. What else? It's a quadratic equation. So when we get to this point, we have to factor. Factor. Okay? So what do we look for when we're factoring? Yep, something that multiplies to negative 6 and adds to 1. Okay, multiplies to negative 6 and adds to 1. What is it? Okay, I'm going to write it over here. If I have negative 6, 3, and 2, can they both be positive? No, which one's got to be negative? The 2, right? 3 times negative 2 is negative 6. 3 minus 2 is 1. So we got it. So now we just write b plus 3 and b minus 2 equals 0. And then what do we do next? Yep, treat them as their own. So I have b plus 3 equals 0 and b minus 2 equals 0. And then just solve both of those equations. So I would subtract 3 over here. So we have b equals negative 3 and b equals 2. one more step we have to do. Can both of those answers be correct? What? Do we know? How can we check if they are correct? Plug them back in. Yep. So I want to check -3. So if I plug it in, I have 6 minus a -3 equals -3. Okay, what am I going to get in that square root? What happens to two negatives? Make a positive, so 6 plus 3, 9, equals -3. What's the square root of 9? 3. Is that a true statement? Does 3 equal -3? No. So -3 is an extraneous solution. Since we plugged it in, it didn't work out. -3 is an extraneous solution. Okay, let's try 2. Square root of 6 minus 2 equals 2. What's 6 minus 2? 4. Square root of 4? 2. Did that one work? Yes, so what is our only answer? 2. B equals 2. Okay. So 14 is the radical by itself. Yes, so what do? Square both sides. So we have 12 minus m equals, what's m to the second power? Yep. Now, we have m to the second power, so you know we need to get everything on one side. Okay, so get everything on the same side. So I'm going to add m, and I'm going to subtract 12. So I have m squared plus m minus 12 equals 0. Okay, when we get to this point, what are we looking for? Multiplies to -12, adds up to 1. What do we got? 4 and 3. Can they both stay positive? No, which one's got to turn? A 3, yep. So when I have my two factors, sometimes we get lost. What's my next step? How do I write them? Yep, m plus 4, m minus 3 equals 0. Next step is to what? Treat them as their own. So we have m plus 4 equals 0 and m minus 3 equals 0. So then solve both of those equations. So you get m equals -4 and m equals 3. Can we be done? Why not? Yep, we have to check. Since we have two answers, we have to check which one is correct or if both are correct. Okay, so which one do you want to plug in first? -4. So plug it into the original. 12 minus -4 equals -4. What do we get in the radical? 16 equals -4. Square root of 16? 4. So is this a true statement? No. So -4 is not one of our solutions. So now we have to do the same thing for 3. Okay, we can't just assume 3 is the right answer. So we have 12 minus 3 equals 3. So we get the square root of 9 equal to 3. What's the square root of 9? 3. Is this a true statement? Yes. So m equals 3 is our correct answer. Okay. So look at 11. We have two radicals. Can we square right away? Yes. Yep. So take square both sides. So we have 19 minus a equals a minus 1. What do we want to do next? Okay, get a on both sides, or on one side. So we have 19 equals 2a minus 1. There's 2 more steps. Add 1. 20 equals 2a. Last step. Divide by 2. A equals 10. Good. Okay, radicals by itself, what can we do right away? Square it. So we have n squared equals 10n. We have an n squared, so what do we need to do? If we have an n squared, we want to get everything on one side. So get everything on that same side, so I need to subtract 10n. So I have n squared minus 10n equal to 0. Ideas on what to do from here? Can we do what multiplies and what adds to? No, because what are we missing? We're missing a c, right? We have our a, b, we're missing our c. Okay, what was the first step of factoring always? Remember? What do you always look for first? Can we take anything out of n squared minus 10n? What do they have in common? They have an n in common, right? Do they have anything else in common? No. Okay. So if I take n out, what's left? N minus 10 equals 0. Okay? What do we do from here? We have our factors. Now we can treat them. Yep, treat them as their own. So we have n equals 0. And we have n minus 10 equals 0. So n minus 0 is already solved. So we just need to add 10 on this one. So we have n equals 10. I need to check. Yep. If I plug in 0, can I take the square root of 0? So if I plug in 0 equals, we said 0. Is that a true statement? Yes, so 0 works. Let's plug in 10. We have 10 equals, what's 10 times 10? 100, square root of 100. 10. Did that work? Yes. Okay, let's look at this one. Is the radical by itself? No. How do I get it by itself? Add p over. So we have the square root of 5p minus 36 equals, I'm going to put p minus 6. Now radicals by itself, what do we do? Square. What's it going to look like on the other side? If we square the other side. Can I just do p squared and 6 squared? You gotta treat it as a couple. Yep. Because you're squaring both sides. So if there's more than one term on the other side, you have to treat them as a pair together. Okay. So what happens on our left side, like usual? 5p minus 36. How do I do this part? What does that mean? There's 2 of them, right? Because that squared means multiply it by itself. So we have p minus 6 times p minus 6. So what do we need to do with that right side? Foil it, yep. So I have 5p minus 36 on this side still. Now I'm going to foil that other side. What is p times p? P to the second. P times negative 6. Negative 6p. Negative 6 times p. Negative 6p. And then we have negative 6 times negative 6. 36. Okay. Before I move on, can I do anything else on that right side to make it a little simpler? Yep, combine like terms. So I get negative 6p minus negative 6p, negative 12p plus 36. Okay. Now what do we do? Yep, we have a p squared here, so we want to get everything on one side, on that same side. So I'm going to add 36 and subtract 5p. Let me come up here. So we get negative 5p, nope, sorry, p squared minus 17p plus 72. And then it's all equal to what? 0. Yep. Do when we get to this point right here. Factor, right? Again, we're thinking of what multiplies to 72 and adds up to what this time? Negative 17. Yep. What do we think? Factors of 72 that add up to negative 17. And then why do they both have to be negative? Yep, because we have to get to a negative 17 and two negatives multiplied to get a positive number. Okay, what do we do once we get our factors? Plug it in, so we have p minus 9 and p minus 8 equals 0. Next, treat them as their own. P minus 9 equals 0. P minus 8 equals 0. And then solve both of those separately. Add 9. So we have p equals 9 and p equals 8. Okay, are we done? No, we got one more step. We got to make sure they work. Okay, so we got to plug each of those in separately. So I'm going to plug in 9. So we have negative 9 plus the square root of 5 times 9 minus 36 equals negative 6. I'm going to teach you a trick. Okay, this negative 9 right here, or this negative p it was, can we already have it on the other side when we plug things in? Yeah, we don't even need to write it how I just did because we simplified it to this form right here, right? So if you want to go to that part first, you can, or you can stay with the original. Okay. So here, if I added that 9 over, I would have 45 minus 36 equals 5. (45 minus 36) is 9. Equals 5. What's the square root of 9? 3. Did this work? No. So can 9 be a solution? No. And then we have to check 8. So plug in 8. So we have negative 8. So we have the square root of 4 equals 2. What's the square root of 4? 2. Did that work? Yes. So, good job. So, that's what happens when I try to do quick math. So we get 3 here. Oh. So, did that one work? Yes. So both did end up working. So you could have, just like we did with quadratic equations, we could have two solutions, one solution, or no solutions. Okay, so all of those three still apply.